All right, we're gonna just cruise along, continue to find missing stuff. So this right here is actually like the angle bisector theorem, which again, we got a lot of crazy theorems. So when in doubt, when you see something crazy, just realize that corresponding sides are proportional. That's kind of the whole punchline of this. Remember, the whole punchline is just kind of multiplication, furthermore, cross multiplication. So really what this is saying, well, I can relate 14 and x, all right? Because this angle bisector, not to get too nerdy, but this angle bisector splits up sides proportionally. So I can say, well, I'm going to take 14 and relate it to x. Well, then that's going to correspond to 11 plus DC. Now, what the heckin' is DC over here? All right, well, realize just some quick thinking. If the whole thing's 20 and the right side's x, that means this left side can be described as 20 minus x. All right, we've seen similar stuff like this before. So it's going to be 11 over 20 minus x. All right, and again, when I have junk, when I have multiple terms, I like to put it in parentheses, so when I cross multiply, I don't forget to distribute. All right. And then again, just a quick recall, there's multiple ways. Like you could say, well, x over 14 equals 20x over 11. That's legal. You might be doing this on your own and you might be having different stuff than me, but as you're checking your work, realize that's legal. You could say 14 to 11. You could do both those sides, and then what relates to 14 would be x, and then 20 minus x. That'd be legal, so on and so forth. All right, bunch of legal things, but realize in any case, just as long as you match up the corresponding parts, these two things will multiply: the 14 and the 20 minus x, and the 11 and x. All right, then once you get to here, you're going to distribute. I believe that's 280, but let me check my work. 280 minus 14x plus 14x and x equals 11.2. In this one right here, we're going to skip the similarity statement. Skip. All right, in this one right here, though, same thing. This is I even forget what this theorem's called off the top of my head, but when we have the parallel line, this isn't a mid-segment, but when a line parallel to a side of the triangle, then it breaks it up into two similar triangles. So this could be like the parallel line theorem of a triangle, who knows what it's called. But nonetheless, let's know how to apply it. All right, a bunch of ways we can say, well, 8 relates to x minus 4. That's gonna force 6 to relate to 12. Okay, cross multiply, we're going to get 96 equals 6 parentheses x minus 4. Distribute, 96 equals 6x minus 24. Add 24 to both sides. 120 equals 6x. Divide both sides by 6, and x equals 20. And in this case here, we'll write a similarity statement. Triangle AEC is similar. So remember, like the first triangle, it really doesn't matter the order you go in, AEC. Well, in the second triangle, the order is going to matter. Well, what corresponds to A? That's going to be B. What corresponds to E? That's going to be D, and then C. And then again, if we want to get super nerdy, talking about, well, since it's parallel lines, those are corresponding angles are congruent, and then angle C is congruent to itself by reflexive property. That's kind of a general summary of stuff we've done earlier in the year. All right, so now we're going to do some perimeter stuff, perimeter. All right, so given that the two triangles are similar, all right, so we got two triangles that are similar, ABC and XYZ, and the scale factor of ABC is 3 to 5. All right, so I'm just going to kind of rewrite this over here. This seems to be important. So this is kind of like a test strategy, is to extract key information that's going to seem to be important. All right, we're going to find the perimeter of ABC. Well, the perimeter of XYZ is 80. All right, so I'm going to write P of ABC. We don't know that, but the perimeter of XYZ is 80. All right, and ABC is the smaller triangle. All right, just to kind of steer us in the right direction. So some side notes really fast. Scale factor for sides equals the scale factor for perimeter. And that makes perfect sense. Why? Well, perimeter is just a bunch of sides added together. So they have the same scale factor. All right, so I can say, well, if the ratio of their sides is 3 to 5, well, that should equal the ratio of their perimeters, which we need to find ABC, over 80. All right, and I'm going to delete that and just call it X. That's going to make it a little easier moving forward. But then just cross multiply, 5X equals 240. Divide both sides by 5, and 240 divided by 5 equals 48. So that's it. Just knowing that the scale factor of sides equals the scale factors of perimeters. They're the same. All right, and that's really just going to help us in this next problem right here. Find the perimeter of the first smaller polygon. All right, so they gave us two, what do you call these? Pentagons. Are they regular pentagons? Do we know all the sides are the same? Not necessarily. But we realize, well, this is a scale factor of 3. All right. So I could easily just divide it by 3. That's one way to do it, and say, well, the perimeter is 15. But we're going to do it the traditional way and just match up the side lengths. So we're going to do the scale factor for sides and say it equals the scale factor for perimeter. So 3 to 9 over the perimeter of the smaller one, 45. Okay, cross multiply, we're going to get 9P equals 135. Divide both sides by 9, and P equals 15. All right, so that's how you do that kind of stuff. Stay tuned for more.